Hello everyone, welcome to my shop. I'm Robin. Thank you to all the viewers. Thanks for stopping back, thanks for subscribing. And had a nice visit this week from Tom Lipton and Alex Kern. Alex is the one who made the nice smaller 1, 2, 3 style blocks for Tom. Did a beautiful job on them, as Tom showed in his video. And we just really had a nice time. We hit it off. Obviously, 3 machine guys in a machine shop, you can't go wrong. So it was nice being able to share things. And Tom is a nicer guy in person than he appears on video. So yeah, really a great time. So in this video, I'm going to be making some insert cartridges for indexable insert tooling. And I start off with a block that's already squared up on size. And I'll cover squaring in another video, but in this case we start at that point. I don't really make that clear in the actual scenes. In the second video, I'll be covering some interesting things about grinding as far as crash modes, how parts can, analyzing how parts can move with the grinding forces, thinking about how parts are held, surface finish, how it affects holding power. Lots of little details there that if you're interested in surface grinding, you'll probably want to definitely want to watch the second video also. The point of this video is to show the surface grinder as a metal removal machine. A lot of people think of it as just flat surfaces and removing just light finish cuts. You can blast material off with a surface grinder, and I'll be showing in this particular case that staging the parts for all the different facets on these insert cartridges is a whole lot easier with magnetic holding and being able to do, I'm doing 3 of 2 different kinds of parts, 3 each of 2 different parts, and how it's easy to stage parts in groups so you're doing operations on them all at once. And even though these parts could be milled and be perfectly fine, I'm showing how grinding is maybe a better approach in this case. So should be interesting, and let's do this. Here's a job where I'm making some insert cartridges for a customer. These go bolt into some other main part of the cutter body, and I'm doing 3 of each. This is one that's considered straight, and then there's this one that is 45-degree angle, and they're using a screw-in style insert, and so I have to use I'm using the sample insert and screw here. This is a 1/4 inch IC inscribed circle insert, and making these out of A2. And the procedure I'm using here is, since I'm doing 3, I'm taking the major axis that has the most features on it, and I'm saying, okay, I'm going to make a block long enough this way in this direction to accommodate all the blocks plus saw cut plus allowance. So I'm doing the cross section of this on the end of this block. Same way on the other one. And what we're doing here, this is the block that matches this one. You can see I've got my scribe lines on here for where I'm going to saw this, and to match this cutout, and then the details on the end here, the actual angles. What's important, one note, is that when you're doing this type of thing, you need to think through ahead sequence-wise to what's going on. I could go over the saw and say, okay, I'm going to saw this out, and then we'll saw these off and everything. But now when I go to do my grind, I might want to be sitting this way to grind on this face. So in this case, it wouldn't really matter, but it's always good to think ahead and make sure that some of these things you might say, you know what, I need to leave this till the last operation because I need to sit on it or reference edge on it or whatever. So this is the block for that one. This is the block for this one, and you can see we've got our blue Sharpie on here. These are just lines for me to saw this out first, then I'll surface grind it. And in this case, this is an example. I'll saw this, I'll mill this, and I'll well, in this case it doesn't matter. I'm going to saw both of these out, and I'll mill them, and then I'll come over on the surface grinder and I'll clean these up, clean the shape up both directions, and I'll even come in here and put this little 45-degree edge on there. Anything that's on the cross section that you can put on full length, it means I'm not going to have to pick up individual parts and put them in and put a detail on one piece at a time. So that's what we're doing, and we'll go to the saw. I'm stoning the Rollin saw surfaces to get rid of any burrs or embedded chips or anything that's not a smooth surface here, because we're working with already surface ground parts. So we have to be careful that we don't, as we clamp these in the saw, if there's any burrs or anything, we'll end up putting a dent in the part from those chips. So very important to stone off the saw before you start. Sawing out the extra material here on the Rollin saw, very handy to be able to clamp the part, have a straight line cut. You don't have to push in the parts. I'm not concerned about them moving or skidding. And controlled feed rate. I have a real nice, very aggressive Starrett blade on here. Sawing the other corner out with the bandsaw. Just going by the layout lines. Coming across from the end. Getting rid of the major material. There's everything removed off the one piece. There's the other one that needs the angled cuts on the end, 30 degree I'm showing there. And in this saw we can put this sideways and clamp end to end, so we don't have to try to do angled cuts having to come into the edge of the part. So pretty handy. Now I'll turn around and get on the other side using a 45 degree that we have to cut there. The other side, you're on the bottom. There's my line that you're seeing that we're going to use to visually align with. Got my 45 gauge on the left hand side there that I'm holding the angle. And then I'm clamping with my chin on the cam lock on the saw to get that angle. And then sawing off the 45. Again, here you can see how sawing angles is real easy with the clamping arrangement there. So still quite a bit of material in there, but we're going to blast that off with a grinder. The hydrodynamic action works on well-stoned blocks and chuck also, not just the surface plate. So here I'm getting ready to stage the two pieces that have the same step height and depth from the front edge. And you see I placed the one in there on its nose. And the other one goes in, same location, making sure everything's clean, always wiping everything off chuck and part. Be adding blocking to the back here so that these parts can't skid endwise, and forcing the pieces in with my fingers snug while I tighten the chuck and down. Here we're coming in with the wheel, just getting ready to touch off, and just touch off on the part to get our initial starting position. And then here we will just touch off on the edge of the wheel, on the back side of the wheel there I'm touching off to establish where I am, and just taking a plunge cut there, creep feed, where I go in and take a cut. Take another little deeper cut, and then we're going to move out and check with the micrometer, see where we are, and set our dials accordingly. Now I've moved over the full amount, which is almost 30 thousandths, and taking that full cut very slowly with the full face of the wheel. And I don't have the coolant in the ideal position here in this particular cut. Later on you'll see one where I move the coolant up in a better position. But here's where we're just moving our material, fast forwarded there toward where we're coming out the end. You will see a little burn at the top because of poor coolant placement, but these parts at the moment are soft, so it doesn't cause any real issue. But this is a quick way to remove a lot off facially instead of just pecking away at it with the side of the wheel. You're using the face, the actual outside diameter of the wheel to do the cutting, where it's a better conformity ratio of grind. And here we're just taking a spring cut. We went in until we actually caught the surface again, and it's sparking out. There's the finished surface, and We'll check again with the mic, make sure we're where we need to be. Here I'm using a razor blade just to cut into the corner of the wheel and see what kind of radius I've got on the wheel, and I dressed it back until I was happy with the radius that I had left on the wheel. Now I pick up with that freshly dressed corner to get back touching that finished face, getting ready to actually start to plunge down in depth now to take this thing to the vertical thickness. We're going to be just reciprocating, down feeding a few tenths of the per pass, reciprocating quickly, and plunging down till we get a clean up where we can do a measurement. So we've gone down till we've cleaned up completely, and you can see there where I've got basically full wheel contact cleaned up there. Now we're just going to move over full wheel width. We've raised the wheel up, and now we're going to come back down to the same setting as we did on the back pass, basically just to remove the material quickly. So that's how you can not have a lot of wheel breakdown, by just straight plunging a few tenths at a time. Here we're going to check where we are, see what our measurement is, and then we are going to correspondingly go back and replunge those surfaces, taking off the amount we need to get down to thickness. So all happens really quick, faster than going over to the milling machine and trying to mill and then come back and forth between the two parts. So plunging again, moved over, plunged again. Obviously took a little longer than this. This is sped up and cut down in time, but now we've got our full width. Now we'll measure again, cleaning off where the depth gauge is going to hit. We're shooting for 4375. We're within a tenth, which is plenty close enough for what we're doing here. Here I'm using a piece of carbon rod to pry the parts up, break the stiction loose. There's the grind finish and the face grind. You never want to slide parts on the chuck if you have a choice. So I'm using that stick, pretty handy, to just pop parts up and get the vacuum, the suction there to break loose on the pieces. And then same way with the 1, 2, 3 block, put a clamp on there, get the pry bar under the edge of the clamp, pop it loose, get that broke loose. Just a good way to get things off the chuck. Squeegee is also something that you might not think of, but works really well on cleaning the chuck off. Depending on your coolant, you might want to put a piece of Viton sheet stock in there for the squeegee, because it'll break down otherwise. Doing the other step on this side of the part, the opposite side, everything's been stoned and cleaned. We're pushing up, we're using our back block so the part can't skid down the chuck. Holding everything in place, putting a little finger pressure on there as I tighten the vise. And same procedure here. We come in, touch off, see where we are, take a creep feed cut through this edge to establish it. Now you see I have the coolant in a much better location up at the top of the cut, so the coolant's carried down through. That last coolant placement was not good. It worked, but this is, you'll see here, this is much better. There won't be any burn at all on the edge of this part when we come back. It's also important to, the wheel will wear some as it goes through. It's always important to make sure that you've got an actual cut full length. Here I'm using my the end of the calipers to measure the step height here. Obviously I checked and deburred the edge there on this outside, and then make our adjustment, creep feed through again, full amount that it needs to be removed. Cable drive is fairly important on this. If you've got a really sloppy gear drive on your grinder, you might have issues with creep feeding through like this, because it is basically climb cutting. Checking my height there, again using pieces to pop your parts off, break the suction. You don't want scratches on your part or your chuck from dragging the part off over grinding grit on the chuck. Here we're using a angle head from a square head, 45 degrees, to set the part in to do this little 45 chamfer. You notice we're removing all of the material with the grinding wheel. So we're going to come down and touch, see where we are, get the coolant on, and this is purely visual. We're going to the scribe marks. A lot of these, most of these dimensions here are not real critical. We're just using the grinder as a metal removing machine, as a convenient way to do it. So here I'll just grind down to the scribe mark. I was sped a bit and grinding down till I see my mark. Then a little traverse grind side to side just to smooth up the surface. You'll also tend to wear a slight groove in the wheel. There's the chamfer ground on. And now we've got another angle to do. We're using the angle blocks. That one's just a riser block that comes in the Brown & Sharp angle block kit. And I believe this is 45 degrees that we're going to do this other side on. Couldn't fit it the other way. The square head from the combination square wouldn't work for this, for the first side, so that's why I'm switching over to the angle blocks on this. See me pumping the clamp there to make sure I'm sitting square, making sure the part settles and isn't squirming, so I know everything's sitting properly. Once it feels real good, then I just snug it up and we'll grind from there. It's a fair amount of material to remove off of this, if you remember from the saw pictures. But same procedure here. We're just plunging down 2/3 per pass, both directions. Each end I'm feeding down, and decent coolant. I don't have coolant blast in there, but enough to just keep the part cool. And I'll go down visually till I can see the getting close to the marks. And you notice there's could be like a fuzzy hair kind of burr that forms on the edge of that. Using the Hastings triplet there to take a look at the edge to see where I am, and grinding accordingly. You can get pretty precise with that, actually. Doing a little traverse cut across there now, just to see where things are. Take another look with the Hastings triplet, and grinding a little more based on what I see there. And now we'll take a little closer look. And we're seeing the ground surface and the blue surface and the scribe line. And as you can see, we're looking right through the Hastings triplet with the camera, which actually gives a pretty good view. It's important to get rid of the burrs that form on each surface that you do, so that they don't interfere with your clamping in the subsequent steps. I'm using a file here, but you can stone them, whatever. Here we're doing a 30-degree bevel, and I just have 2 parallels in there to hold me in approximately the height that I'd like above get the surface above the top of the chuck, using a Starrett angle gauge out of a angle gauge kit. Basically, it's a pack that has them all in there. I remove them so they're individually accessible. In the pack, they're kind of hard to use. So here we're gently snugging up the vise, and then we double check, make sure that our gauge is fitting well, and remove the parallels, anything that's loose, because it's that much less to clean up with the coolant. So here we'll touch off on the top, and start to grind on that. And same procedure, we'll just down feed into this till we get to our scribe, checking our scribe line there with the Hastings triplet, see whether we're in place. This was wider than the wheel, so I have to move over. I've raised the wheel up, and now I'm going to come down to the same 0 and just plunge down on that to remove that material quickly. Once we get down to the bottom there, we will traverse, as you see, just to smooth things across, blow things off, and remove the part. And there's our nice 30-degree bevel, and we'll deburr that and carry on. Deburring this piece on all the edges, on both sides. It's a number 4 cut pillar file. Really like the pillar files with the safe edge on both sides. Now we're sawing one piece off of each of the blocks that is a little longer than the finished length of the part. That's the one block. Blow it out. Roll one saw. We're cutting the other one. Notice how I stop in there. These parts are the same width. And you can see my layout lines where my saw blade's going down between those. And we will then grind the remaining double length piece on the end so we don't lose our squareness. Stoning the chuck with the precision ground flat stones. Stoning the 1, 2, 3 block surface. Wiping the chuck. It's always raining grit and dust in the shop. If you're grinding, you've got stuff raining down on your chuck. That's why we're wiping constantly. You can never wipe enough. The 1, 2, 3 block is blocking these parts so that they can't tip over endways or skid down the chuck. And I'm letting one piece block the other, holding them firmly as I tighten the chuck so they're slid tight back against each other and against the 1, 2, 3 block. Checking their tightness on the chuck, making sure they're firm. Here we'll touch off on the top, and all we're doing here is cleaning up so that we are maintaining the squareness on this end that is already established on the other end that's actually on the chuck. So that's why we only sawed one off and grind these immediately so that we maintain the squareness of the pieces. Here we don't have a lot to take off, so I'm taking maybe 3/1000ths off and doing a normal, traverse type grind across. Taking a finish pass across here just to improve the finish a little bit. I'm not measuring because this isn't critical, it's just going to get sawed. Here I'm taking the pieces off the chuck. I'm pressing down hard as I bend them over to break them loose. Don't lift and bend, press down hard and bend. I've already cut one piece off at the correct length, and then this is the last piece that I'm just trimming the excess off. But I have not lost my ground surface off of each end. So all of these are now sawed to the same length, and I'll be able to put the ground face down on the chuck. Tapping these down gently. Even when you're very, very careful, sometimes you can get just minute particles, and you can sit on one and it'll keep you from actually getting down tight to the chuck. Here we're doing plunging, a few tenths of the time at each end of the stroke, full wheel width, moving over back to the same, down to the same zero in each position, moving over the last stripe, down, plunging. Just getting all the material off to establish a datum. Cleaning off to get my depth gauge on there, 564.3. I'm headed for 562, 9/16. It's not critical. If I'm within a couple thousandths, it's good, but easy to hit closer than that with the grinder. 562.7 is within 2/10, which it doesn't matter. Taking parts off, using the clamp and the carbon fiber rod to break things loose. Same thing here, putting a clamp on, sucking that piece off now, pressing down hard, and using the Knipex parallel pliers there to just do a little twist. Press down hard, twist. If you lift, you have a tendency to rebound and actually smack the chucks. I'm not gripping hard with the pliers, I'm just getting enough there to be able to twist the parts and pop them up. So like I said, secret there is press down hard and then just rock up on the edge. Here we have the three pieces in the magnetic V block, and blasting that material off. Now we're checking see where we are with the Hastings triplet to take a look at where we are and determining how much we need to take off. After they're done, removing it from the magnetic V block, turning it off. As always, looking for some means to, if possible, take things off without sliding. Everything will last longer in your grinding environment if you don't slide things off.
These are the other ones. Did the same operation to these. These are the, notice the end of these is different. It's the one with the 30 and the 45. Same 45-degree relief on it.
I have a 15-degree bevel that needs to go on this surface here. The magnetic V-block is a really nice way to hold these pieces, especially since I have 3 and they all just happen to all fit in the length of this. So I'm going to use that to my advantage, and I'm going to tilt this angle block 30 degrees, and since it's 45 the way that it was sitting in there, that'll give me my 15 that's left. Now normally I'd love to just sit this underneath this and let the magnetic V-block sit on that and clamp it, but as you can see, the aspect of this is just not conducive to it sitting on there because this won't fit on the vise or the other way. So not really a problem. We're just going to regroup here, and I'm temporarily going to see, I'm going this direction. I'm going to temporarily just hold this angle gauge here. Get my Allen wrench for the magnetic V-block, and I'm just going to turn this on gently enough to hold this. Get this flushed up here. Now this is also holding itself. The magnetic V-block is holding itself to the vise now, magnetically. So I can now take this and indicate this in using this. I don't have to be actually getting this where I'm engaged. Get the indicator lined up here. Make sure I've got room to travel. Yes. And now we can just traverse, come down on this, get engaged, and traverse on this, and just adjust this until we get this lined up nicely. Still a little high. Yeah, we're getting in the ballpark. There we go. So now we need to go the other way, just a trifle here. That's more than adequate for what we're doing here. It's just a clearance. It's just a clearance flat on the bottom of the tool. But of course, we can't let it go being off a few tenths. So now get the indicator out of the way. Come back here to see the whole setup. Now we can see that we've grabbed the V-block now with the vise, so it's not relying on magnetism anymore. And now I can just slide this off because I just had it gripped lightly, and we can stack our pieces in and grind our 15-degree angle on there. Loading in the pieces, just making sure they're sliding in smooth. Slide down here. You gotta be careful that they don't jump on each other like they just did there. This one's got to move down to the end. There. Okay, magnet on. We're ready to grind. That's my medium rear cover that I have back here, and not quite tall enough for this, so I'll put my tallest cover in. Slatches in the back here with a grip and a hole location, so I can slide up and down to get any height that I needed there on the back.
Now we're grinding that 15-degree bevel, just plunging down on it and removing all that material, and finally taking a traverse pass after we get down to the line. Releasing it from the magnet. Now grinding the same 15-degree bevel on the other set of 3, the one with the 45 and 30-degree angles. Exact same procedure, just going down and going down to the layout line.
I need a 10-degree bevel on this portion right here on these pieces. Still like to use the magnetic V-block because it's a convenient way to hold these. So in this case, I'm using the large V on this side, small V's on the bottom, and it actually leaves enough room that I can use the angle block and actually just set it in there on the angle block to set the angle here. So I've got a 35-degree block there, subtracting from my 45, giving me the 10 degrees that's left there. So I'm stoning these pieces off screen, sliding them in place. And one of the things that's important here is you always have to think about the actual motion that the part will take from the forces of the grinding wheel. Grinding wheel is rotating in this direction. It's pulling this surface, so you have to think, okay, what can happen? We have very little gripping surface down here at the bottom. This part is not stable by itself. This part can cock like that, and in this particular case it's somewhat rolling out of contact with the wheel, but not completely. So this is basically a crash waiting to happen. So you have to do things to prevent that. That's what blocking is for. Have a nice block here that's got ground surfaces everywhere, and what I'm doing is I'm backing up here, saying, okay, I've got all these parts in place. Now I position them such that I've got a decent bearing area here for where the parts are grabbing, plus a good substantial grip on this. Now I slide, make sure my parts are actually staying put, and I slide these up very carefully up against each other, make sure I'm seated on the bottom. Now the forces here are absorbed by this block, and now this part can't just tip over as I grind. So blocking is important. It's very important to think about the forces the grinding wheel are putting on the part and what will happen if the part's moving. If you have big, huge surfaces, large stance on the part, that's all out the window. But as soon as you start getting these little teeny parts with less actual area being gripped magnetically, very, very important. Now that I've got them all in place, I know they're all touching each other, no room for any motion. I turn my magnet on. Always check, always push on your parts the direction the wheel is going to push, and make sure that they're stable, that you don't have something. Number one, if you forget to turn the chuck on, which can happen, you'll catch it in that. So it's always good to turn the chuck on, always before you grind, push your parts.
Plunge grinding down on the face there, going to the layout line as before. Little traverse, and that's the end of those parts. There's the flat.
Here's the 10 degree that I just did. Now we need a 45 degree on here, on removing this corner on all the pieces. So I could take the vise off and set this down, since we're actually doing a 45. But since the vise is in there, it's easy to clean off. I just set two half-inch parallels here to set the magnetic V-block on, basically to give me room that my wrench still clears. That's why I can't set it down all the way in the vise. Now here's a case where the blocking is really critical. Remember we said think about which way the part is going to go when it gets pushed by the wheel. So forces in this direction, the wheel drag going this way. Look what happens when this part comes in here. This rocks up into the wheel. This is your classic horrendous wheel crash, where the part actually gets a bite and self-feeds into the wheel. Can take a chunk out of a grinding wheel in a big hurry and cause a heck of a crash. So very important to be aware of that. Always think about how the part's getting pushed. So this is real important, more important than the last side. This one's really important to be blocked properly, so that these parts are prevented, hopefully prevented from doing that. When I say hopefully, meaning this, you have to remember that this block, if it skids, can let these parts do what we just saw. But because of its larger mass, the more lines of flux are going through this from the magnet, it's got a better grip than the parts. This shouldn't be a problem. So we're pressing down and back, down and back, down and back on each part, turning the magnet on, checking, making sure our parts are tight. I'm pressing on these hard. I'm actually leaning on these, make sure the parts are good and stable.
Here we're plunge grinding down on the corner, the 45 degree. Just removing the material. Like before, we're just going to the layout line for the position. Doing a traverse pass there, just for finish. Here they are ground.
Hope you enjoyed that, and there's lots more and some more detail in part 2, so please check out the second video. Thanks.